Hi there, Mr. Holcomb here with another episode of the Math Behind the Modules. Okay, so in this exercise, lesson 6, where we're talking about the distance between two rational numbers, you are all to get in groups of 2. Pair up. One person's person A and the other is person B. Using a number line, each person independently counts the number of units that make up the distance between the two numbers listed in his or her assigned column. The teacher may want to provide students with larger number lines. Since I'm not here, I just would suggest that you use the number lines that you have in your book. Okay, so here's what we're going to do. Pause the video and have person A and person B work each column independently, and then come together when you're done and see what your results look like. Pause the video and start it back up when you're done. Okay, so after pausing the video, let's take a look at this exercise. So what is the distance between -4 and 5? Well, -4 is right here, and 5 is right here. So 1, 2, 3, 4 to 0, and then 1, 2, 3, 4, 5 to 5 is a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. What is the distance between -5 and -3? -5 is here, -3 is here, 1, 2. The distance between -5 and -3 is 2. What is the distance between 7 here and -1 here? 1, 2, 3, 4, 5, 6, 7, 8. Okay? So there's our comparison for person A. Now person B has a different set of values. What's the distance between 5 and -4? Here's 5, and here's -4. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. The distance between -5 and -3, 1, 2, and the distance between -1 and 7, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here it says this difference between -4 and 5, so that'd be -4 plus 5. Over here it says 5 and -4, which means 5 plus a -4. So our equations are in a different order, but we are getting the same result. And you should see that you're getting the same result in each one. Okay? And why is that? What property tells us that the order does not matter? So now we're going to do exercise 2. Students now work independently using the formula to find the distance between each of the two given x endpoints. You should verify your answer by using a number line model. So pause the video, do exercise A, B, and C. When you're done, unpause the video. Okay, now that you've done these, let's take a look. And it says, what is the distance between 0 and -8? 0 to -8 is a distance of 8. It is not -8. Distance is always positive. Distance is the absolute value of the number we're dealing with. So the absolute value of -8 is 8. Okay. So let me show you that mathematically rather than just writing the absolute value of -8 is 8. What we could do is write the absolute value of 0 minus a -8 equals the absolute value of 0 plus 8. That's the absolute value of 8, which is 8. Okay? And if I write it this way, it means we started at -8 and counted this way. 0 minus a negative 8. We're getting rid of that negative 8. Like it's like discarding our negative cards. It's the same as adding. Okay, what is the distance between negative 2 and negative 1.5? So, absolute value of negative 2 minus a negative 1.5 equals the absolute value of negative 2 plus 1.5, which equals the absolute value of negative 1/2, which equals positive 1/2. So we're starting at negative 2, and we're going to the right 1, and then a half. Oh, I'm sorry, that's not true. We're not subtracting this. What is the distance between? So here is negative 2, and here is negative 1.5, and that distance is 1/2. What is the distance between negative 6, right here, and negative 10? So the distance between negative 6 is the absolute value of negative 6 minus negative 10, which equals negative 6 plus 10, which equals the absolute value of 4, which equals 4. The distance is 1, 2, 3, 4. Okay. Example 1. Formula for the distance between two rational numbers. Find the distance between negative 3 and 2. Step 1, start on an endpoint. So I'll start on negative 3. Count the number of units from the endpoint you started on to the other endpoint. And I'm going at positive 2, so I count 1, 2, and my answer is negative 1. Okay. Alright, disregard that last example. I'm sorry, I read that incorrectly. Try this again. We're not adding 2 to negative 3. We're finding the distance between these two values. The distance between negative 3 and 2. So I need to put a point at negative 3 and a point at 2, and the distance between is 1, 2, 3, 4, 5. So the formula is negative 3, absolute value, plus 2. But it's not plus 2. It's negative 3 minus 2. So we aren't going to use the plus here, we're going to use a minus. Negative 3 minus 2. The distance between, we can work it this way, which might be a little more confusing to you. Negative 3 minus 2 equals the absolute value of negative 5, which equals 5. So I'd be starting at 2 or subtracting 2 from the negative 3. We also could do it a different way and take the absolute value of 2 and subtract a negative 3, which equals 2 absolute value plus 3, which equals absolute value of 5 plus 5. Okay? So down here it says for two rational numbers p and q, the distance between p and q is the absolute value of p minus q. So here's p, here's q. So we took the absolute value of p minus q. And that's where this minus sign came from. So let's try that again. Example 2. Change in elevation versus distance. Distance is positive. Always positive. Distance is positive. change in elevation or temperature may be positive or negative depending on whether it is increasing or decreasing. In other words, going up or down. A hiker starts hiking at the beginning of a trail at a point which is 200 feet below sea level. He hikes to a location on the trail that is 580 feet above sea level and stops for lunch. Okay, so he starts at 200 feet below sea level. We take the absolute value of our starting point minus the distance he traveled, which was up to positive 580, so it's P, negative 200, minus Q, 580, absolute value. So that is going to equal the absolute value of negative 200 plus a negative 580. Minus means plus a negative. Which is going to equal the absolute value of negative 780, which equals a distance of 780 feet. How should we interpret 780 feet in the context of this problem? The hiker hiked 780 feet from a point below sea level. To a point above sea level. Okay. So now we're moving on to part B of this example, and it says after lunch, the hiker hiked back down the trail from the point of elevation, which is 580 feet above sea level, to the beginning of the trail, which is 200 feet below sea level. So here's a vertical number line. So if I just mark up here the height he had gotten, which is 580 feet above sea level, and he ended up at negative 200 feet. Well, before lunch, he climbed up, okay? He ate lunch, stayed there a while, and then came back down. Okay? So this is before lunch, and this is after lunch. What is the vertical distance between 580 feet above sea level and 200 feet below sea level? So you would say 580 absolute value minus a negative 200 feet below sea level equals the absolute value of 580 plus 200, which equals the absolute value of 780, which equals 780 feet. Okay. What is the change in elevation? And it is 780 feet. Before lunch, it went up 780, but after lunch, he went down 780. What is the change in elevation for the entire day? 0. He started at negative 200, he ended at negative 200. They didn't ask that, but... Okay, exercise 3. Now it's your turn. Take the time to do this. Take a few minutes. Work with a partner to come up with a solution to the following exercise. Use a distance formula to verify your answer. Use a number line if necessary. Pause the video. Come back when you're done. Okay, so here we go. The distance between a negative number and a positive number is 12 and a half. What are the numbers? Okay, there are multiple different answers that you can come up with this. Here's one example. If I started with the number negative 9.5, and it says the distance between a negative number and a positive number is 12 and 1/2, what's the number? So a number line might be useful here. So if I draw a number line, and here's negative 10, 9, 8, 7, 6, so on. Okay, so there's our number line. We started here at negative 9 1/2. So when I count 1, I'm going to be on the halves every time. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and a half, and I ended up at 3. So negative 9 1/2 and 3 would be the example here. To show this mathematically, I would say the absolute value of P, which is negative 9 1/2, minus Q, which is 3, equals the absolute value of negative 9 1/2 plus a negative 3, which equals the absolute value of negative 12 1/2, which equals 12. There's many other examples you could have used. If you started here at negative 6 1/2, then you would be over here at 6, 10, so on and so on. Exercise 4. Okay, take a moment to do this. Pause the video. When you're all done, come back, play the video. Here is the solution when you're done. Okay, use the distance formula to find each answer. Support your answer using a number line graph. Find the distance between negative 7 and negative 4. Okay, so the absolute value of negative 7 plus, minus, I'm sorry, that should be a minus sign, P minus Q equals the absolute value of negative 7 minus a negative is plus, which equals the absolute value of negative 3, which equals 3. If I used a number line, this was negative 7, negative 6, negative 5, negative 4. The distance is 1, 2, 3. B, find the change in temperature if the temperature rises from 18 below Fahrenheit to 15 above Fahrenheit. Use a vertical number line. Okay, so 15 is our positive number here. Let's call that P. Negative 18 is our negative number. Let's call that Q. And we take the absolute value of P minus Q. So I'm going to say the absolute value of 15 minus negative 18 equals the absolute value of 15 plus 18 equals the absolute value of 33, which equals a difference of 33. If I use a vertical number line, 0 is here, okay, then we're going to go from 15 degrees to negative 18 degrees. And in order to do that, the easiest way would be to say, well, this is a distance of 15, and this is a distance of 18. And the whole thing is 18 plus 15, which is 33. And that would be a vertical. Okay, C. Would your answer for part B be different if the temperature dropped from 15 to negative 18 degrees? So before we had negative 18 to 15. So we were at negative 18 to 15 for the last example. And it's asking if your answer for part B would be different if the temperature dropped from 15 to negative 18 instead of negative 18 to 15 degrees. Okay, and the answer is yes, they would be different. Because if we use our formula, the distance between 15 and negative 18 is the same distance between negative 18 and 15 because the endpoints are the same. But if the temperature would change by negative 33 degrees because it's going from a higher value to a lower. So it is different because we are decreasing instead of increasing. Our end result is different. One is increase of 33 degrees, the other is a decrease of 33 degrees. D. Beryl is the first person to finish a 5K race and is standing 15 feet beyond the finish line. Another runner, Jeremy, is currently trying to finish the race and has approximately 14 feet before he reaches the finish line. I love these examples. What is the minimum possible distance between Beryl and Jeremy? Okay. So he's not at the finish line, so let's call that a negative 14 until he gets to the finish line. The other guy's already 15 feet beyond the finish line, so we'll say plus 15, or minus 15, I'm sorry. P minus Q, I keep putting the same thing over. Okay? P minus Q, minus 15. Okay, so that is going to equal a negative 14 plus a negative 15, which equals a negative absolute value of negative 29, which equals 29 feet. Okay. You could also do the number line for that. I'll leave that to you if you decide to. E, what is the change in elevation from 140 feet above to 40 feet below? So here's our P, here's our Q, and our formula is the absolute value of P minus Q. So we say the absolute value of 140 minus 40 equals the absolute value of 140 plus a negative 40. Which equals the absolute value of 100, which is 100 feet. What is the change in elevation from 140 to a sea level 40 feet below sea level? Okay. Wonderful. Negative 40. Let me redo that again. This is incorrect, and I don't want to start the video over. So it's 140 feet above sea level minus a negative, because we're below sea level, okay, P minus a negative 40 equals 140 minus a negative is plus 40, which equals an absolute value of 180 feet, which equals 180. My apologies for that error. That's why they make erasers on pencils. Okay, that's the end of lesson 6. Now do your exit ticket and then your problem set for home.